Hey everyone, we hear it all the time, right? Weigh the risks in our health, our finances, our everyday lives. But what does that actually mean? Well, today we're going to build a practical toolkit for understanding uncertainty. We're going to break down the science of risk into some really simple, powerful concepts that you can actually use. Okay, let's dive in.
So, here's our game plan. We'll start with the big one. What even is risk? Then we'll look at what makes a system vulnerable or, able to bounce back, resilient. After that, we'll get into the two main ways experts think about probability, see how they actually put numbers on risk, and then finally, we're going to decode what we really mean when we say something is safe. Every step here builds on the last one, so by the end, you'll have a complete toolkit.
To get us started, let's just use this classic image. Picture this, a massive boulder just sitting on a hill right above a town. Is it a risk? How big of a risk is it? I mean, where would you even start to analyze this? This simple picture actually holds all the complex pieces we're about to unpack. Okay, first things first. Before we can measure anything, we need a solid blueprint. We have to define exactly what we're talking about when we say the word risk. Trust me, it's a lot more than just a vague feeling of danger. Now, this is a really important but subtle difference. On the left, you've got the risk concept. That's the idea of risk in our heads. It's got three parts: an event, let's call it A, its potential consequences, C, and the uncertainty around it all, U. So the boulder might fall, it might crush some houses, and we're just not sure if or when. That's the concept. But on the right is the risk description. And this is how scientists get really specific. They define the specific event, the specific consequences, and here's the key, they replace that fuzzy uncertainty with actual probability, P, and they note the strength of knowledge and the background knowledge it's all based on. The whole point is moving from a general idea to a specific evidence-based statement. So we've defined risk, but that definition has two big parts: the chance of something happening and what happens if it does. This next section is all about that second part, the consequences. And that brings us to vulnerability. Now, this formula might look a little technical, but I promise it's super simple. It's the consequences, C, and the uncertainty, U, and that vertical line just means given that. So given that the event, A, has already happened, we're not asking if the boulder will fall anymore, we're asking, okay, it fell, now what? And this quote just nails it. It separates the outcome from the chance of the event itself. I mean, think about it. A town built out of reinforced concrete is way less vulnerable than a town made of straw huts, right? Even if the chance of the boulder falling is exactly the same for both. Thinking about those consequences naturally brings up a related idea. It's not just about the initial hit, but about how well the town can actually handle it and recover. And that ability to bounce back, that's what we call resilience. You can think of it as the town's emergency services, its community spirit, maybe its financial reserves. Now, it's really tempting to say that low resilience is the same as high vulnerability, but they're not quite the same. Resilience is a key input to vulnerability. A town that can't quickly get the power back on or treat injured people, a town with low resilience, is going to suffer much, much worse consequences. And those worst consequences are what vulnerability is actually measuring. Okay, so we've talked about events and we've talked about consequences. But what about that U for uncertainty? To measure that, we need a tool. And that tool is probability. But it turns out there are two very different ways to think about what probability even is. So on one side, you've got the frequentist approach. This is probably the one you learned in school. It's all about how frequently something happens over many, many, many trials. Then on the other side, you've got subjective probability. This isn't about infinite trials. It's about an expert's degree of belief based on all the evidence they have right now. The frequentist view is absolutely perfect for things you can repeat, like rolling a die. You roll it enough times, and the frequency of hitting a 6 will get super close to that true probability of 1 in 6. Makes sense, right? But here's the catch. For most real-world problems, like our boulder, you can't just repeat the event an infinite number of times. That true frequentist probability is a theoretical idea. It's a model we build in our minds. It's usually unknown, and we have to estimate it, which, introduces its own uncertainty. Subjective probability, on the other hand, is perfect for these one-of-a-kind events. A geologist can't roll our boulder down the hill 1,000 times. So instead, they look at the soil, the weather, the seismic data, and they say, okay, based on everything I know, my degree of belief that this will fall this year is, say, 80%. The urn is just a clever way to calibrate that belief, to put a number on it. So the huge point here is that this kind of probability is always tied to the knowledge behind it, P given K. It's not about finding some single true value out there in the universe. But, and this is a big but, it's only as good as the knowledge supporting it. If you have a weak foundation of knowledge, you're going to have an incorrect probability. So we've got our consequences and we've got our probabilities. How in the world do we combine them to get a single measure of risk? Well, one of the most common ways is something called expected value. Expected value is really just a weighted average. You take every possible outcome, you multiply it by the probability of it happening, and then you just add all those results together. It gives you what you could call the center of gravity for the risk. Let's just walk through a super quick example. Let's say we're looking at the number of accidents on a road next week. There's an 80% chance of 0 accidents, a 10% chance of 1, and so on. We just multiply across each row, then sum up that final column. And boom, the expected value is 0.37 accidents. But, and this is a huge but, you have to be so careful. That simple number, 0.37, it hides a lot of complexity. It doesn't tell you anything about the worst case scenario. Maybe there's a tiny, tiny chance of a 20-car pileup, but the expected value just papers over that. It also doesn't tell us how confident we are in those probabilities in the first place. So, expected value, it's a useful starting point, for sure, but it's never the whole story. All right, we have built up quite the technical toolkit here. For our final piece of the puzzle, let's connect all of this back to a simple, everyday word we all use without even thinking about it: safe. Think about it. When you say an investment is safe, or that a playground is safe for your kids, what are you actually communicating? Are you saying there is zero risk? Probably not. Almost never, actually. And here it is. This is the big reveal. From a risk science perspective, safe does not mean zero risk. It's a value judgment. It means that you or someone has looked at the risk, whether formally or just in your gut, and decided that it is acceptable, it's tolerable. And this, honestly, might be the most powerful takeaway from this whole explainer. Safety isn't some absolute state of zero danger. It's a decision. It is a line that we draw in the sand based on our values and the information we have that separates the risks we're willing to accept from the ones we're not. So there you have it, a basic toolkit for understanding the science of risk. We've gone from distinguishing the concept from the description all the way to understanding vulnerability and the flavors of probability. So the final question is for you. Now that you're armed with these ideas, how does it change the way you see the world? What risks look different to you now? Thanks for tuning in.
So again, let's reflect a bit on this video, because we cannot just take an AI-generated video for granted. So overall, I think it was accurate, but there was one part that was wrong, and that was the part where she said we need a tool to measure uncertainty, and that tool is probability. Well, that is not true. Looking at the risk description, we have a measure of uncertainty, and that splits up in probability and strength of knowledge. So probability is a part of the uncertainty, but we also need the strength of knowledge component. Other than that, I think it was a good and clear video that can be used perfectly well besides studying the course material.